Well, good afternoon and welcome back, everyone. When it comes to the testing on data assets, this is something that very few people seem to be getting right. And one of the areas that certainly bears a lot of discussion and further experimentation. And here to help us with that is Nicole Radziwill. Nicole, welcome.
Thank you.
And she's going to be talking to us about Pareto testing, optimizing the value of tests on data assets. So over to you, Nicole.
Thank you so much, Derek. So hello, everyone. Thanks for connecting this afternoon. I'm looking forward to connecting with you here and sharing with you some of the experiences that we've had, particularly over the past 3.5 years as we've been building a data quality engineering practice that's servicing mostly Fortune 500, Fortune 1000 firms, but also things that I've picked up along the way since the beginning of when I started working in data, working around data. And I'll tell you a little bit about that in a minute. What I did want to start out by saying is that this term Pareto testing is a shorthand for saying, hey, when you go to most large enterprises, there's hundreds of thousands of things that you could potentially test in your data ecosystem. So the question is, how can you choose the 20% of the work that you could put in to solving that problem to generate 80%? Are we back?
Yes, we're back. If you could share your screen again.
Wonderful. Okay, let me know when you can see it.
Yes, can see it.
Fantastic. So for those of you who've been attending sessions over the past couple of days, some of the themes that have come up are things like the importance of really connecting your data quality assurance efforts to the business value that those efforts end up creating impact for. Another theme that's come up is there's so many things to test. We can't just hop in and boil the ocean and test everything. So, what are some ways that we can look at changing the nature of this story so that we can do a small fraction of the effort, but get the 20% of the effort to generate 80% of the business value. So that's going to be the theme that we focus on today in this session. And what I'd really like for you to do is come out of this session with some new ways of thinking about how you can plan or phase your controls catalog. And these things are very long duration, long effort initiatives. This isn't something that you can just get done in a 3-month project. So what I'd like for you to take out of this are different ways that you can approach planning and executing a controls catalog that really does drive business value for your organization. So a little bit background about me. I started out in the mid-90s as a meteorologist. I was working on research instrumentation, building new systems to derive water vapor data from GPS satellite signals, from some junk signals, and started working on data quality. And then that got me interested in the business aspects of data quality. Since the mid-90s, I've done several different things, but served in a chief data officer role at a national lab for a few years. Then I went to a university and I was a associate professor of data science and production systems for about 10 years. And more recently, 5 years ago, I went back to industry because I'd been studying quality and digital transformation for a long time. And I thought now is probably a good time to go back and start practicing the things that I've been teaching my students and start practicing the things that are really going to drive value for organizations right now. So a lot of that information is captured in the book you see on the right-hand side. That came out in 2020. And so I invite you to go check that out too. We're not going to be covering that in this session because we're going to be focusing on the value of taking a Pareto approach to testing your data assets. So this is a quote from an HBR article that just came out last month. It's written by Randy, who you may have seen yesterday or the day before here, and also Allison, who's one of our advisors, who's a really fantastic chief data officer. In their article, they mentioned that across all of our organizations, and this is from Randy's annual survey that he puts out to organizations like ours, just 23.9% of those organizations say that they've created a data-driven organization. So it's not surprising that we should be wanting to focus on how can we really accelerate our impact? How can we really focus on driving value through data? But what I think we're missing the opportunity to do is, instead of being completely focused on the business, focus on using those same approaches to create a data-driven data organization. So, what I started thinking about when I was helping Ultranauts build a data quality engineering practice was, how can we walk the walk? How can we use some of these same approaches and really help our clients apply data to manage their data-driven organizations better? And so that's where this idea of applying the Pareto principle to generating and carrying out a testing strategy came about. And as we talk about this, we're going to focus on 3 different areas. The first area is just the concept of quality controls in general. What are controls? What are all the different kinds of controls that you can implement? The second section we're going to talk about is taking a value perspective on the data journey. What does it really mean when you look at lineage from that perspective of business value and impact? And most importantly, how can you teach your teams to start doing that? And then finally, I'm going to show you an example of Pareto testing, blinded from the organization that it comes from. And what you'll be able to see, I hope, is that by being, and I like to call it, by being strategically lazy in how we approach our testing, we can actually make data quality assurance better, faster, cheaper, and have more impact. So these are not new themes. You've probably heard some of these themes begin showing up in some of the talks that you've gone to today or over the past couple of days. And we're going to start by diving into quality controls. So one of the areas that people tend to be very familiar with the concept of controls is cybersecurity. So if you take the example of, look at the picture on the right-hand side, we've got a computer. Imagine that there's something really, really important. It requires the utmost of care and secure conditions on that computer. And the computer is sitting in a room behind a big door. We've got some, maybe a firewall. That's the image of the fire across the doorway there is intended to suggest a firewall. We've got a big lock. There's all these different ways to protect that data. And you can think about those controls in 4 different categories. These categories come from the concept of cost of quality. So the 4 categories are prevention, appraisal, internal failures, and external failures. And basically, this is intended to suggest that tests are not the only form of control that you can have. So in this security case, there's a lot of things we can put in place to prevent issues from occurring that threaten our security. We can install that door. We can put a lock on it. We can create, we can to install antivirus software. We can train people on the standard operating procedures and the right ways of carrying those out. We can help train people on how to engage in this environment and contribute to a secure environment. But we can also install some tests. Maybe we can test for malware, or perhaps we can put a sensor on the door so that if the door is open for a certain amount of time, it can start beeping and then call the attention of someone who's around who can then perform a corrective action. However, we can't prevent everything and we can't detect everything through appraisals and audits. There's going to be failures, and there's two distinct kinds of failures. The first failure is, our controls have failed, and it's impacting people internal to our environment. So maybe your colleagues, maybe your friends, hasn't touched your customers yet, but someone local has noticed. So you're basically giving yourself the opportunity to take corrective action without huge costs. But if the failure happens and it impacts your customers, or it impacts your suppliers or someone outside of your organization, the comparative cost of that is going to be much higher than if you caught that issue yourself. So when you think about the concept of controls, the first point that I want to make is to start thinking about them in terms of these four categories of prevention, appraisal, internal failure, and external failure, because the corrective actions we take as a result of the failures are just as much quality controls as training or governance or running tests on our data assets. If we think about quality controls for data in terms of these four categories, this is not an exhaustive list, but some of the things that you might encounter in your organization, in addition to tests, are things like supplier qualification. How many of you purchase data from large organizations? Usually it's really expensive data. Most of the time you have a choice between different vendors that you can go with, and all of the actions that you take in advance of making that purchase are quality controls. You can also do regular audits on those suppliers, make sure that they're following their own procedures for ensuring quality. Input validation is something that you see on lots of forms. Data contracts are a new and emerging way of thinking about how to connect your data producers and your data consumers with more of a quality mindset in place. There's lots of different things that you can do to prevent those quality issues from occurring in the first place. And we all know that once the issues occur, there's ways to detect whether they're there. Data observability systems, they help us figure out if arrivals are coming on time or at all, so that we can anticipate downstream failures that might depend on them. We perform process audits on the business side. I haven't seen as many companies perform them on the data side, but I am seeing it more and more. Understanding the people, process, and technology that comes together so that the data can satisfy a particular goal, and then auditing those processes the same way that you would for auditing an operational process if you have an ISO 9001 certification. There's also different controls that you can put in place to force internal internal failures, like, for example, chaos engineering. And then, of course, just like in security, just like in operations, you can have CAPA processes, corrective and preventive actions. And through those CAPA processes, you take action that then improves the quality of your data systematically. Data observability is, of course, one of many kinds of controls, and we're fortunate enough in 2023 to have access to many, many different types of controls. So observability, even though it's one of the newer trends that's emerged in the market, it won't catch everything, nor should we expect it to. In particular, data observability platforms can't see through silos. That's one of the things that process audits tend to be a lot better at. So my appeal to everyone watching today is, when you think about your controls strategy, make it more heterogeneous. Include many different types of controls, because it's through the combination of the controls that you're really going to get the rigor that protects your data and makes it fit for use and fit for purpose across many, many different people and roles who need it. So you can think of these quality controls too through the lens of a maturing organization. So as an organization's maturity with respect to any kind of quality increases. This is going from left to right. The numbers 1, 2, 3, 4, and 5 correspond to any of those 5 level maturity models that you may have seen or been exposed to, where 1 is the starting point, and then you move up all the way until 5 is very automated, very self-serve, highly mature environment. But if you look at the progression of the maturity from the perspective of cost of quality, in the beginning, you just have a siloed and chaotic environment. But by the time you move to number 2, you're saying, hey, let's gather some data to figure out exactly how much we're investing in prevention versus appraisal versus those failures. And so from 2 to 3, you're going from awareness that these are things that you can measure and start to improve upon to actually understanding the distribution of your activities, of your people in the organization, how much time, effort, and money you spend on each of those 4 categories of controls and responses. What ends up happening is that once you start taking a quality focus and collecting the data in these 4 quality cost categories, what you're able to do is tighten the feedback loops so that external failures drop, so that internal failures drop. But at least temporarily, when you're in the level of maturity that corresponds with approximately 4 in those 5 level maturity models, what you find is that you're investing a lot in prevention and less in appraisal. What ultimately ends up happening is that you can tighten those feedback loops so much that you have 0 or nearly no external failures because you anticipate them. Same thing with internal failures. Those go to 0 or nearly 0. And you find out that appraisal, the process of auditing, is nearly automatic, and all you're investing in is prevention. So taking a perspective on quality controls for your data that accounts for, number 1, the 4 categories: prevention, appraisal, internal failure, and external failure, and then coupling that with anticipating how you can grow in maturity. That is one way that you can choose the controls that in combination will help you get the highest level of data quality and continually improve it in a way that meets the needs of your respective people and roles who are using that. Not all quality controls are created equal. The most common example that I see for this, and that many of us here recognize, is that tests that you do upstream are generally more valuable than tests that you do at the very, very end point, when you're just verifying to someone, yeah, that thing you saw that you think was wrong, it's definitely wrong, or test showed that it's wrong. Far more valuable to be able to catch the issues upstream so that you avoid the waste and rework of all the downstream actions that you're going to have to do again. And also so that you can anticipate those issues and you can respond to them before they cause issues, particularly with your customers, but to some degree your internal customers as well. There's low value quality controls, not to say that they aren't valuable, it's just that they're less valuable than the high value quality controls. Things like if you're doing a supplier audit for the third-party data providers that are providing you with information, if you check to make sure they're following their processes every year, every 2 years, that's obviously not going to be as high value as if you have complete coverage of testing on all your data pipelines and all your data assets. Similarly, if customer accounts and your product catalog are super important to some of your business processes, then having good coverage, good tests on those for the lines of business that you want to focus on, those are going to be higher value than the things like the supplier audits, which you do less often and that address a different level. So as you're thinking about the different levels of value of your quality controls, the most important part is shifting your perspective so that you think about designing good quality into your processes rather than just using tests to inspect the bad stuff out. It's through this philosophical shift that you can start moving away from, and I heard this phrase so many times over the past couple of days, you can move away from the whack-a-mole approach to data operations, and you can start moving towards the protective and preventive actions that get you better processes where the errors don't happen in the first place. So how do you identify your vital few? That's one of the terms that you'll hear when you hear people talking about the Pareto principle. Pareto principle first came about when the Italian economist Pareto started studying income inequality. And what he found out was that in Italy, 20% of the families held approximately 80% of the wealth. And so they started studying the same principle of inequality and looking at Lorentz curves and Gini coefficients to try and figure out exactly how unequal are these systems that we observe. And throughout the next many decades, the presence of power laws, the emergence of the Pareto principle was observed in many places. The two that I see most often with our customers are that about 20% of your customers are going to be the ones that generate the bulk of your profit. And similarly, but more unfortunately, it's also probably about 20% of your customers that generate 80% of the nonsense that you have to deal with. So, this shows up all over the place. And in the 20 to 30 clients who I've personally been part of working with over the past almost 4 years, it's really uncanny how frequently you see the Pareto principle show up. So we decided to say, how can we use this for planning and activating quality controls on our data? So if you think about your data ecosystem and you're trying to figure out what is the 20% of my data or my data producing processes, what are the ones that I should focus on? There's some heuristics that you can use to help you figure that out. High value data, I'm gonna go straight to high value. That's data that a lot of people need very often. Those are things like the reports that your entire sales team gets every morning, and they use those reports to make decisions about which prospects they're going to target that day. Data that supports high dollar decisions. We work with one organization where we were trying to help them improve the data around the allocation of their marketing spend, which is a really important issue in many companies. For this one, it was particularly important because their marketing spend was about $1 billion a year. And so they really wanted to make sure that all of the data flowing in and through their marketing models were going to give them some confidence about the output from those models and the amount of trust that they place their decisions in. When you have data that supports high risk decisions or can mitigate them, or maybe data that is mission critical or ties directly to the health and safety of your workforce, that can give you a clue that there's a high value data use case that you can focus on to be able to apply the Pareto principle and choose the good subset of quality controls. Data that's less value are things that not many people need, or maybe they use it, but not that often. Or maybe it's data that takes an awful long time to put together. These are the, I call them trash boards, because they keep your data analysts really busy, but the comparative value that you get out of the hours they toil over those metrics and those dashboards just aren't that significant. So those are examples of low value processes around the data in your organization. So when we took this concept to our clients, we said, if you could think of all the possible tests that you could apply on your pipelines, on your data assets, all of the other controls that you might place on different aspects of your data flow, not all of them are really important. So if you're starting from a green field where you have a CFO saying, I want you to spend as little money as possible and get me a high ROI on this test initiative that you want to launch. What we decided to do was say, okay, if each data flow has a story, and that story is closely tied to business value and impact. So, for example, if you think about the story of how that data flows to a particular person or a particular person playing a particular role, let's just look at all of the tests that might be relevant to that particular business use case. And let's see if by looking at the results from our quality controls, very selectively chosen to be relevant to those data stories, let's see what kinds of output that's going to give us. And so that's where we're going to end up at the very end of this presentation. But before we get there, I wanted to take a quick look at what do I mean by the value-driven data journey. And as we're going through this discussion, I also wanted to focus on something called separation of concerns, which is, if you're a software engineer, you've heard about this, you've used this since day one of your career, most likely. And it's one of the most helpful things that contributes to software quality that I don't see us applying in data nearly at all. So I'm gonna tell you a little bit more about that. So again, going back to the concept of data quality maturity. Let's say your organization is a greenfield, and so you want to know, where do I start? I want to improve data quality, but I really, really don't know where to start. Where I usually advise companies to begin is pick 1, 2, 3, if you can, high value business use cases where data plays a starring role. One of the organizations that I'm advising right now, we're looking at their opportunity pipeline because they want to help their salespeople select the best opportunities on any given day to close better deals faster. And in particular, they want to improve the interface between sales of current products and sales of new products in R&D, and they recognize that the data quality around that process is holding them back. So the first thing that you might do is say, let's just do an audit of our data quality around those high value use cases to figure out what is the story of how data generates value for that particular use case. What does good really mean? Does good mean different things to different people? And if we're trying to determine whether the data in that particular use case is fit for purpose, whose purpose? Who are these people who have these needs? One of the most interesting things that we discovered was that even given one singular data story, one singular story around the value that data produces, you can have 2 different people who use 2 completely different lenses for how they evaluate data quality. And what we've recognized is that that's one of the reasons why you can end up with engineering teams saying, look, we've done all these tests on the data and it shows things are perfect or nearly perfect. How come you, business user, have a problem with it? We've proven that it's perfectly fine. One of the things that we've noticed is it's because everyone applies a slightly different lens based on what their unique needs are from that data. So anyway, if you're starting in a greenfield, the first thing that you do is just take a look at those high value business use cases and figure out what data elements drive business value, how do they drive it, and for whom. Once you have that information, you can start moving to a position where you can start automating some of those tests. There's several vendors that have been here at the event that do this sort of thing. You decide what your expectations are for data at various stages of that data value story, and then you set up those expectations programmatically and you run the tests. The tests will tell you whether your data is meeting those expectations or not. That's how you inspect bad data out operationally. But then as time goes on, you can take those automated tests and you can have them running in the background. You can have them tied to corrective actions that need to be initiated if there's an issue that's detected. And so you can evolve those suites of automated tests into continuous warning systems where those tests are always running in the background, and your systems give you alerts. They tell you exactly what the action is you need to do next if a problem is detected. So as you move from left to right throughout these three areas, that's how you go from being able to understand what the requirements are to design good data quality in, to use inspection in a pragmatic, judicious way, and to continually improve the entirety of your approach so that you can shift from reactive to proactive. And one moment, please. So what you're going to see in the next several slides are, look at the bottom middle of this slide. The things that look like bow ties, that's a symbol that I use to reflect pipelines. The bronze colored cylinders, that's raw data. The silver colored cylinders are clean data, and the gold colored cylinders are data products or new information that you've generated using clean data that is then useful to one or more business users. The conceptual model loosely follows the conceptual model that Delta Lake uses. That's my favorite data lake, but I wanted to make sure that you know what those symbols are, because we're going to encounter them in just a second. I promised you, though, that we would talk about separation of concerns. So separation of concerns is a design principle that basically says, in any software, let's design our systems so that they're in logical subsystems where similar subsystems are close to each other in conceptual space, but where they're not so tightly coupled with each other that the failure of one function is going to impact the failure of another function. Where you see this in software design a lot is you'll have a decoupling of the business logic from the user interface code. This is why you hear back-end software engineers versus front-end software engineers. The roles themselves have stratified in order to reflect this separation of concerns. And the reason why this is an important and valuable design approach is that you don't want your button that says go. You don't want that button, if you can't click it, to negatively impact any of your business logic. You want that business logic to run whether you can click that button or not. So by implementing separation of concerns, we're able to make our systems more reliable and more robust to changes, but we don't apply this as often or as religiously in our data ecosystems. And the number one symptom that I see for that is that, a lot of times I go into organizations and I ask VPs of engineering, directors of engineering, I ask them, where do you keep your raw data? And they say, oh, it's in our data lake. And where do you keep your clean data? Oh, that's in our data lake too. Okay, where do you keep the new information that you generate from your data? Where do you keep your data products? Oh, that's in the data lake too. If you ask them to distinguish inside the data lake where the raw data is and where the clean data is and where the data products are, sometimes they can tell you that they're in different areas or different tables. Most of the time, nobody's actually thought about that before. But what I'm about to show you is that applying separation of concerns in such a way where you can tell the difference between your raw data, your clean data, and your process data or your data products, and where you can tell the difference between the different stages of tasks or pipelines that generate that information, all of a sudden you open yourself up to get better information. So look at the bow ties and the data assets down at the bottom there. You'll notice that this is just a very high level conceptual model of what you might do in your organization, where you have pipelines that acquire or load the data. They acquire or load the raw data. A lot of times you might have data observability systems that are attached to this because you want to know if those tables or those files or whatever data you need to perform the next steps. You want to know if they're showing up at the right times that you expect, and if they have the right characteristics to go to the next step. So a lot of times you'll put tests in place right there. I've also seen companies apply tests in place to their clean data, but don't really meet in the middle. So, by taking this engineering approach, you have some tests, you have some results, but you're not thinking so much about how do specific subsets of those tests, how can I look at just the results that correspond to those subsets to tell me if I'm the person who cares about data story 1, can I trust the data that's coming to the report or dashboard that I care about, that I need to do my job? I don't care about those other tests on all the other assets or all the other pipelines. I care about the ones that are relevant to what I need to carry out my job. The conceptual model that we use to think about applying separation of concerns in a data ecosystem is this. So the first column on the left there just represents your arrivals or your data acquisition. What happens as data comes into your scope? The second column is about integration, structuring, cleaning, those activities that transform raw data to clean data. In the middle, in the orange part, we have analysis or processing, and those are the steps where we take clean data and use it to generate new information, things like forecasts, things like classifications, anything that relies upon clean data to get us new information that we use to make business decisions. In the fourth column, we take everything that we've produced, whether the business user wants to see the clean data in and of itself, or they want to interact with the data products. We have to put those on a plate that meets that particular user's need. So we have delivery logic that gets the data products and the clean data to the people who need it. Finally, though, on the right-hand side, there's the value question. So think about the value question this way. If you look at a particular report or dashboard every morning and you use it to make decisions about how you're going to carry out your day, there's a process that goes on in your head that says, open up the report or dashboard, look at this particular part of that report or dashboard, evaluate what you see in a certain way, given certain heuristics to make my decision. A lot of times that last mile of the business value isn't captured by anybody. And it's really fascinating. Like I see this a lot in sales. When you're trying to figure out what value a salesperson gets from a report or a dashboard, you interview 5 salespeople, you get 5 completely different thought processes. And by capturing those thought processes, that gives you a much better platform where you can go back and say, what parts of that data story, what parts of the transformation and the flow processes data, it becomes different things and goes to real stakeholders with real needs. What parts of that are important? You find out amazing things by going to multiple stakeholders and seeing what happens in that last mile when they're using the reports and the dashboards and the analytics that we give them to make decisions. Just as an aside, I've been talking about taking that value-driven approach and applying separation of concerns. One of the most interesting things that our teams have discovered is just the experience of going through constructing a data value story for a particular business use case reveals an awful lot about your controls or the lack of them. For example, it usually takes 4 to 6 weeks to get all of the different perspectives where you can put one of these things together. Sometimes you can't ever get to the endpoint because multiple people in your organization are looking at the same process in such different ways that you can't get a shared view of what's going on. And just, uncovering that there is a lack of shared understanding can provide huge business value for your organization, because it helps uncover where not only where people aren't getting what they need, but where relationships are fracturing as a result of issues with the data. So I'd encourage every organization to go through the process of mapping out their data stories, especially for their vital few, their high value use cases, because just that activity can reveal so much about how to improve your data quality organization wide. Okay, so now I'm going to show you a quick example. This example is blinded from an organization for privacy purposes, but it should give you a sense of the kind of information you can get when you evaluate test results from the perspective of those value stories and look at the vital few tests rather than looking at the entire ocean of tests that we try to that we tend to boil. The example that we're going to show you depends on tests using Great Expectations. You may have heard of this product. It's open source, but they have a cloud product that's just recently gone into beta that should help business users set expectations for data a little bit more easily. But this is an open source package, and at this point, there's probably a little over 300 expectations that you can use to test your data, whether it's coming out of the end of a pipeline or whether it's testing an asset at rest. The company itself, they used to be a healthcare information management consultancy, but they had so many healthcare clients that just needed data assets tested so that they could run those test suites on a regular basis to get that test intelligence, that the whole company pivoted, and now they're a product company. They've just got a huge second round of funding, and so they're doubling down on transitioning this from a tool that's really, really helpful to engineers to a tool that can be helpful to both engineers and business users who care about data. So you'll see an example from Great Expectations in a little bit, and the example of Pareto testing. This particular one is just across multiple Great Expectations test suites, although we envision that the same approach could be useful and valid whether your tests are running Great Expectations or cron jobs or DBT or what have you. So premise number one is that data lineage in and of itself is helpful, but not sufficient to really understand whether the data and analytics and information you deliver to an end user is going to meet their needs. One of the reasons why is that if you're a business user and you look at the lineage output, it doesn't really make much sense. You'll see database table names, you'll see the names of columns or fields that maybe might make sense to one person but won't make sense to everybody. And this is pretty common, right? That IT tools are made for IT people. They're there to help you quickly triage and attack a problem and resolve it, a technical problem, as quick as you can. But those displays generally aren't as useful to business users, especially since in a lot of our organizations, the lineage actually looks more like this. There's so many steps. A mere mortal can't look in here and figure out, hey, I'm a salesperson. Is my report something that I can trust? So what we're trying to figure out is how do we slice through that problem? So this is a screenshot of a test suite that we have running on using Great Expectations. And what you'll see here is that for this particular data asset, and this is just one data asset out of many, there were 66 tests for expectations evaluated against this data asset. And when you run those tests, 98.48% pass. And that sounds great, right? I mean, if you're an engineer, yeah, that sounds great. You're doing exactly what you need to do. But the problem is, if you're the person whose output depends on those one or two tests that just failed, you're going to look at those engineers and say, I don't care that you say the data passed nearly all of its tests and it's 98.48% good. It's terrible from my perspective. And so I don't trust you anymore. I don't trust that your tests are valid. So what we wanted to do is say, how can we start transitioning from an engineering view of tests, the passes or the failures that look a lot like this in our organization, that look like traffic light displays, and how can we generate more meaningful, more useful operational information from them? So before I go to show you how this is done, when you look at when I ask organizations to show me your data quality dashboard, I'll see something like this, or you'll also see dashboards that are like 92% complete, 88% accurate, 78% valid. And if you ask more questions like, okay, how do we drill down into that and figure out what that means? Is that good or bad? Should we take action now? A lot of times engineering groups are unable to answer those questions because it's not how they think about approaching the quality assurance process. Over here on the left-hand side, and where you see 100% pass rate, 51% pass rate, these are all pass rates on suites of tests. So for example, you might have 100% pass rate because a suite containing one test, that one test passed, or you might have 100% pass rate because out of the 200 tests you ran, all 200 of them passed. When you look at information rolled up in this way, it's hard to tell the relative magnitude of those test suites unless you look at a different view. That's what I'm going to show you next, is a Pareto testing view of this. So imagine now, instead of each of those rows, instead of each of those line items, we now have from left to right one pixel that indicates a single expectation on a data asset or on a pipeline. If you see a color, that means the test passed. If you see a black pixel, that means the test failed. So what we've just done is we've just expanded down into a more granular way to look at these test results. Now let's separate them so that the loaders or the arrival processes are down on the bottom and they're light blue. And as you move up, we're distinguishing between loaders or arrival processes and integration or cleaning pipelines and processing pipelines, or models or forecasts, those sorts of things that generate new information. We're also distinguishing those from delivery pipelines, which, implementing separation of concerns, delivery pipelines are just things that populate your Tableau or your Power BI. Now, you might say, well, in our organization, if you dig down and look at the code that's actually driving a Power BI dashboard or a Tableau dashboard, we don't just have information delivered to us, we actually go all the way back, and we have data that's being loaded, and then we clean inside Power BI. And remember at the very beginning when I said that because we don't, as a rule, tend to employ separation of concerns in data, we're missing the opportunity for more information that would actually be really useful to us. That's what I mean. This case that I'm showing you right here, there was a re-engineering effort that had to go in to take these particular data stories and to build them in such a way that separation of concerns was employed. On the top of this, you'll note that we're distinguishing between tests on raw data. Those are the bronze colors. We're from tests on clean data, that's the silver. And then all the way at the top of the screen, tests on process data or data products, that's the gold. In the next slide, we're just going to do one thing. We're going to reorder these bars based on how they occur in time. So if you go from the bottom to the top, the first thing that happens is raw data arrives. It's loaded into your system. Then that raw data is captured somewhere, stored somewhere. At some point, raw data is brought together, it's joined together, it's integrated, it's cleaned, it's restructured, and it becomes clean data. Now we've moved up about 75% of the way up. Using clean data, we generate new information from it. We run processing pipelines, and we have data products. And then those data products are what we deliver to the end user. So all we've done here is we've just reordered the way that we look at the tests. The next thing I'm going to do is show you what happens when you take a subset of these, so that you're looking from the perspective of one data story versus another data story. The two data stories that we're going to look at, one is for a very, very complex dashboard that I would consider it to be of trashboard status. And the second one is a simplified finely tuned dashboard that was re-engineered from a group of sales representatives. Here's what that looks like. All we've done is take a subset of the tests that are relevant given a particular data story on situations that apply separation of concerns. And now all of a sudden, we have a really good basis to say, you know, if I care about the data story that's populating dashboard number 2, I think I can trust the output that's coming out of there. Whereas if I need dashboard number 1, I don't know if the information that's getting in there is something that I can trust. So what we've done is we've turned this perspective from an engineering-based view, a triage-based view, into a business value view, where what hops off the page is who are your stakeholders who are actually going to be satisfied with the information that you're delivering to them. So what are the takeaways? First and most important takeaway is that it's only about 20% of your lineage that matters the most for business value. And one of the ways to uncover that is to start implementing this technique of data stories. They're at a level less granular than lineage that you might see from the IT perspective. But when you draw out that higher level perspective and you draw it all the way to the people who are actually going through decision processes to generate value from the data that you're delivering to them, sometimes you can uncover elements of that thought process that reveal what's important about the data flows that those insights are supported by. The second is that usually only about 20% of your tests that provide the majority of the value. It's those tests that correspond to your high value data stories, things that support dashboards and reports that people use every day, all day, to make really high dollar value decisions. Tests on, for example, your web logs, usually not as viable to the business. And so I mentioned in the very beginning that as we were going through some of these different concepts, what I wanted you to take away was just new ways of thinking, new ways of approaching how you might plan or phase your controls catalog. So as you leave here, as you think about this, think about things like, to what degree is my data ecosystem applying separation of concerns? Can I even tell the difference between where my raw data is and where my data products are? Or are they all kind of tossed into the same place? Ask yourself the question, do I know what my high value data stories are? Or am I treating every single data flow like it has the same value? Because by focusing on your vital few, you can start building tests around those data stories instead of taking the engineering perspective, which is more akin to boiling the ocean. When you do focus your quality assurance efforts on your vital few, your high value data story, you'll find that you spend less time and money to get just as much impact. And your business users are going to be happier because, you know, after feeling like, you know, I heard this from someone just a couple months ago. They said, for years, the engineers have been telling me, look, we have almost 100% tests passing, and we're good engineers. Our tests are good. The salesperson said, it's not that I didn't believe them, but I didn't feel like I was seen. You know, no matter how good they were telling me the data was from their perspective, from my perspective, there were gaps. And he said, finally, after all these years, I feel like I'm being heard, and it gives me a new and renewed sense of faith in the relationships that I can build with the organization that's providing data to me. So I thought that was the best win that you could possibly have, is, you know, using the work that we do to create more reliable, more robust data infrastructures to get people the information and the insights they need, but also to help them build stronger relationships as a result. We're in a really unique position to be able to do things like that. So thank you very much. If you want a copy of the slides, please friend me on LinkedIn and I'll send them to you.
Hey, Nicole, thank you. Thank you so much. Really comprehensive manner in which you dealt with the topic. There are a couple of questions that have come up, and I want to just ask you for your thoughts on them. You may have touched on a couple of these things already, but if you can kind of summarize it in a nutshell for us. The first one is, what are some smart metrics that can be applied for usage of this approach in a practical manner?
The number one metric that you can use is coverage, and coverage not from the engineering perspective of how many of our data assets are we performing tests on, but coverage of when I look at the data flows that are the most critical to my business. I might have a few thousand data flows, but these ones here, these 20 or 30 are the ones that the business really relies on. Look for test coverage across those high value use cases that we call data value stories. And when you do that, if you can get to nearly 100% coverage of tests, you're going to end up getting more of the value than if you attempted to get higher coverage from the asset or the pipeline perspective.
Right. Okay, and here's the second one.
Okay. What
are some smart metrics that can be applied for usage of this approach in a practical manner? Oh, sorry, that's what I've just given you. There's another one. Okay, are the 20% of the tests that provide 80% of the value typically the same tests across organizations, or are they different?
So that's really interesting that somebody asked that question, because so we've now done things like this with this particular approach, almost 20 organizations, and not all organizations have had us start at the same starting points. But it's really interesting because as the teams dive in and start building these data stories and putting together the test strategies based on them, we're noticing some commonalities. I'll give you the best example that I've seen so far. We had an organization come to us to say, we really want to improve the data quality of our price quotes. We think that the data quality in the price quotes is terrible. Help us, right? Turns out it wasn't the data quality and the price quotes that mattered. It was the data quality in the product catalog, because it was that was inhibiting moving their opportunities to close deals. Mm-hmm. So obviously that's not going to be a universal thing, but we're noticing some definite movement towards objects that are more critical than others, even for use cases that might not at first glance seem totally related. So do you think that answers the question?
Yeah, I think so, largely. I think the underlying theme that you've brought out here is very much in line with a lot of the things that people who are closely involved in data governance have been talking about now for quite some time. And I think it meshes nicely with it, because in data governance, a lot of people talk about critical data elements. Mm-hmm. And there's a lot of people got really confused about data quality initially, and they were trying to make everything perfect, and
yeah.
And you can't.
Yeah, everything doesn't need to be perfect, it turns out.
Yes, that's right. And it's amazing how if you just go over after, start small, go after the most important things, and then it starts catching on after that. People start seeing the value of investing in data quality. So
yeah.
So
it's I was just going to add to that most of us are in a situation where our data ecosystems have grown up like a Frankenstein, right? Not so much in the larger companies who've been working on these problems, for 20, 30 years, but in the mid-sized companies, you see it started out with like one person, hey, you can be the data guy, make this better for us. And then, maybe that turned into 3 people or 5 people, but we're really dealing with the historical evolution here that's led us to believe some data elements are more critical than others. We've taken action based on that, and then we've been frustrated because we're just not feeling the value that we thought we'd get out of it for all that investment. So that's exactly where we started along the path of maybe there's a different way. Let's try it. And now I'm interested in doing a little more rigorous research on it to figure out whether some of these observations, like you said, are more global than not.
Yeah, yeah. Fascinating stuff. I think I'd love to talk some more about this, but maybe we can do that offline.
All right.
and
Sounds
I'm sure that a bunch of people that have been watching this as well will reach out to you. And to the audience, remember that you can continue to raise questions in the platform, and I'm sure Nicole will be interested in checking those out and possibly responding to them as well in the platform.
Certainly.
Beyond this session today. Well, I think we are right on time, Nicole. So
thank you, Derek.
You very much for a great presentation, and all the best going forward.
You too. Thank you.